goal of this video will be to quickly talk about the purpose of the anesthesia machine, then to trace the flow of gas from the walls and the cylinders all the way to the patient to understand how it flows through the machine. Third, to talk about tank oxygen and gas capacities. Fourth, to briefly talk about how the vaporizers work that deliver the gas in the machines. And then fifth, to briefly talk about the circle breathing system. So the purpose of the anesthesia machine, first and foremost, is to deliver oxygen to the patient. Second function is to deliver a precise mixture of gas to the patient. Third is to be able to deliver positive pressure ventilation. And fourth is to remove waste gases. Modern anesthesia machines also have the capability, as you're well aware, to have an integrated monitoring system for the patient and to port that data into the EMR to be collected. So now to talk about the two sources of gas for the modern anesthesia machine, there is the wall supply, which supplies the anesthesia machine with gas 99.9% of the time. And as a backup supply, there are the E-cylinders, which are there essentially for emergencies. It's important to note that both the wall supply and the portable tanks have a safety system in place to prevent the user, which would be you, from plugging in the wrong tubing for the wrong gas. For the wall supply, this system is called the Diameter Index Safety System. People call it DIS, and basically based on pins on the tubing, it prevents you from plugging in the wrong tube for the wrong gas. Similarly, for the E-cylinders, there is a poorly named acronym, the Pin Index Safety System, and very similarly, it prevents you from plugging the wrong tubing into the wrong tank so that you don't deliver the wrong gas. Okay, so now knowing the two supplies of gas for the anesthesia machine, let's look at how that gas flows through the machine to the patient. So start by orienting yourself on this picture to the two supplies we just talked about. There is the pipeline supply, which is what we were calling the wall supply, and the E-cylinders, or the portable oxygen tanks. So you'll see at this highlighted joint, and just focus on the bottom half right now, the oxygen side, where that circle lies, you can see that the gas either flows in from the oxygen pipeline or the oxygen cylinder. Now, what determines which is supplying the anesthesia machine at any given moment is which has the higher pressure delivered into the circuit. The oxygen wall supply, and this is the same as the nitrous wall supply, will pretty much always be delivered at a pressure of 55 psi. On the other hand, we know the full oxygen tank has a pressure of 2000 psi. So the question is, why doesn't the circuit always just draw from the oxygen tank if that pressure is higher? Well, it's because the circuit right at this elbow joint has a pressure regulator. And what that does is it drops the pressure of the oxygen cylinder or the nitrous cylinder from 2000 psi to 45 psi. And what that does is it ensures that the oxygen pipeline supply pressure is always going to be higher than the oxygen cylinder supply. So at any given moment, the anesthesia machine is going to be drawing from the oxygen pipeline supply. However, as you can imagine, if the oxygen pipeline supply cuts off and suddenly goes to zero, the oxygen cylinders are well positioned to suddenly jump in and start delivering the oxygen. So that's the system that'll come up on exams. Ultimately, the gas then makes its way through the circuit, passes through a few safety features, and comes into the flow meters, which we're very aware of. We use that to titrate the amount of gas. Then goes through the calibrated vaporizers, which we'll talk about it, and then finally makes it out to the outlet, which is where it feeds into the actual patient circuit that the patient breathes through. A few safety features to briefly talk about. First, there's the second stage oxygen regulator. This simply further reduces the pressure in the circuit from about 45 psi to 14 psi to make it safer to deliver to the lungs. The failsafe valve is a safety feature that ensures you have a good oxygen supply to the patient. If the oxygen pressure falls below 30 psi, it will turn off all non-oxygen gases to ensure that you have good oxygen in the circuit. And finally, the oxygen supply failure alarm, which will alert if the pressure of oxygen falls below 30 psi for greater than 5 seconds. So essentially alerting you that there's a problem with the oxygen supply from either the wall or the cylinders. Okay, and so now to briefly return to portable gas tanks, also known as E-cylinders, and some of their specifications. Partially because it's clinically relevant, also because this will be on exams, so you will know this table inside and out. And the big picture of it is that oxygen tanks, the oxygen in that tank exists as a pressurized gas, whereas in a nitrous tank, the nitrous oxide exists essentially as a pressurized liquid. So the the PSI in an oxygen tank gives you a sense for how much oxygen is left in that tank because the pressure is proportional to the volume. However, for a nitrous tank, since it's liquid, the PSI doesn't really change as the tank depletes. Rather, you have to look at the weight of the tank to figure out how much nitrous you have left. Okay, so now to quickly talk about the two types of vaporizers that are used in modern anesthesia machines. The first is called a variable bypass vaporizer, and that's what's in play for sevoflurane and isoflurane. So how a variable bypass vaporizer works is you can imagine you have your liquid form inhaled anesthetic, and that liquid inhaled anesthetic has a little bit of saturated vapor pressure, so there are some molecules that are right above the liquid, ready to be picked up. And what the variable bypass vaporizer does is it pushes gas over the liquid anesthetic, picking up some of that saturated vapor pressure so that then you have a gas form of the inhaled anesthetic to deliver to the patient. And the way that you titrate exactly what concentration that is exactly as the name suggests. You vary how much gas passes over that liquid anesthetic, and that determines essentially how much you're picking up. So when you're turning that dial, literally what you're doing is varying how much gas passes over that pool of liquid anesthetic. So the second kind of vaporizer is called a measured flow vaporizer, and it's associated with desflurane. It's also called a Tech-9 vaporizer, and the way that it works is totally different, and it's due to the fact that desflurane, unlike sevoflurane and isoflurane, is nearly boiling at room temperature. So, you can imagine there are a lot of molecules of desflurane right above that liquid pool, and any small change in temperature will cause the saturated vapor pressure of desflurane to really fluctuate. So you can't just pass a certain amount of gas over desflurane and expect a normal concentration to come out of it because it's so variable based on the temperature. So instead, what they do with this Tech-9 or measured flow vaporizer is essentially boil desflurane so that the vaporizer knows what saturated vapor pressure it's dealing with, and then directs a certain amount of gas through that chamber to pick up a known saturated vapor pressure based on what you titrate. All right, the last thing to briefly talk about is the circle circuit, which is how we ultimately deliver the gas to the patient. So now if you look at the fresh gas inlet, you know the whole rigmarole that it took to get the oxygen from the wall supply or potentially from the E-cylinders to the fresh gas inlet. So that's where gas enters the circuit. You'll notice that there are inspiratory and expiratory unidirectional valves, so that ensures that gas flows only one direction. And what's important to know is that when we're using a circle circuit in our anesthesia machine, we are essentially using it as a semi-closed circle circuit. You'll hear about other circuit types, notably the Mapleson circuit, which is a more linear circuit with a lot more waste of gas. Not as relevant clinically, but you'll definitely see it on exams. And so that is the anesthesia machine at a glance.